All right, greetings everyone, and welcome to another exciting episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, that's right, we are continuing on with our Python programming series. Joining us back in the studio again today to lend his enormous expertise on that very topic is our good friend and mentor, Mr. Justin Dennison. Justin, welcome back to the show, sir.
Thanks. I'm glad to be back.
You seem excited.
I'm so excited. I also, we keep perpetuating this mythos, and I'm just going to go with it.
Yeah, you should.
I'm just going to go with it. So today, we've got these final few data structures that are the core part of Python. So we're gonna talk about dictionaries. But before we talk about programming, because dictionaries can kind of be of a weird feel. If you come from a JavaScript background, you'll be like, that kind of looks like JavaScript, but not quite. When I go to look up a dictionary, right, and I open a dictionary and I go and I do a lookup. I'm like, okay, here, the word apple, and I can find a definition of an apple. So a dictionary is very much a lookup like that. It's a mapping, almost like an association that I can artificially impose. So this kind of happens with strings and lists already behind the scenes. So when I do, if we hop over to the terminal, just so we have some frame of reference here, if I do, the string A, B, C, D, E, right? There is actually an association made for me by the string that A is the 0th element. But sometimes indexing by numbers are not the most intuitive or the best way. And Daniel, if you'll allow me to, I figure the best way to talk about these associations is maybe a little like word association game. Right. So when I say a word, you say the first thing that comes to your mind.
Well, this ought to be fun.
This ought to be fun. So, cracker.
Hamstring. Say the first thing that comes to your mind. So.
Car.
Wheel.
Bus.
Driver.
Taco.
Stand.
So these are effectively what we're doing programmatically in a Python dictionary. We're creating these associations that when I say, hey, give me this, it'll spit out a plethora of things. I can get a number back, I can get a string back, I can get a list back, I could even get another dictionary back. But I think that's a little beyond the scope of right now, the introduction. But it's effectively a way to, instead of having zero-based indexing, I can use other means of indexing or looking up these values. The first thing we need to realize, though, order is not preserved. So because there's this association that isn't created with numbers, Python behind the scenes will find the most efficient way to store these in memory, so they don't always come in the order that you think they would. So we have to be very careful about that. But let's go ahead and look at a simple dictionary. So this would be our first dictionary, and let's say for one, right? So we have a number, but it's actually a string. We have the number 1, and for the number, for 2, we have the number 2. So if I do this, and I'm just going to print this back out, you'll notice the order has already changed. So behind the scenes, I'm not guaranteed this order, like 1 is always going to be the first one, 2 is always going to be the second one, or however I define them. Also, I said that we're going to get rid of some of those curly braces. Well, they do crop back up. This is a way of defining a dictionary in a literal sense. Like, I want to make this where 1 is associated with the number 1. But now I effectively have a collection where instead of going, I want the 0th element, like in the string up here, right? So if I look back at the string, if I want the 0th element, then I get A. But in this dictionary, I can't do that. If I actually try to use a lookup, this is a common error we'll run into with dictionaries. I have the string 1 and the string 2. I don't actually have anything that's associated with 0, so I get a key error, and it'll actually tell me what key it is. And this is important if we're trying to iterate through some things. And hey, you're trying to ask me to look up something, and I don't know what this is.
So you just basically trying to put chocolate with peanut butter here, there, even though that's a tasty treat.
That is tasty.
But in programming, it's the I guess I should say more like oil and water. They're not mixing because they don't go together.
Right, right. It's kind of like if you go to a normal dictionary that you would look up words in, and you try to look up a word that's in a different language. And you're like, oh, it's not there. Bueno, it's not there.
So that makes sense.
Right.
Yeah.
So how do we actually access these properties within dictionaries? Well, I can say first dict, and if I say find the element associated with the string 1, it goes, well, it is the number 1. So I can create these more intuitive relationships that actually come in handy, and we'll see how this works shortly. But a dictionary, Daniel, if you had to take a guess, you think dictionaries are mutable or immutable?
I'm going to say mutable because it just seems to me that if I can change things in a dictionary, I can make them do whatever I want.
As I said always, Python's very intuitive, and Daniel, I have to applaud you. Great work. You're taking this all in. You're doing great. I hope everybody else is taking this all in like you are. So if I actually want to change the association between the word 1 and something else, right? Maybe I want to change, instead of it being associated with the number 1, I want to change it to, let's say my number 1 favorite food, right? I can say 1 equals carrot. I don't get an error. Let's see what the dictionary looks like. And I now have 2 is associated with the number 2, 1 is associated with carrot. So this is incredibly powerful. So we've just seen that dictionaries are in fact mutable, which, as you said, Daniel, makes them incredibly powerful.
Yeah, and instead of having to go in and redefine the entire dictionary so that I can make that one change, I have the ability to just select where I want to make the change, do that, and say, here's what I want to do. Before I had 1 equals 1, the actual number 1, or the number 1 equals the word 1. Now I want it to equal carrot because my definition of what I want 1 to be has changed. Therefore, I can make that change easily.
Exactly. Now, there's some other things, and just right off hand, I wonder if some of the things that we've used for lists are applicable to dictionaries, or what we've applied to strings are applicable to dictionaries. So, when I start getting this intuitive feel about a language, I'm more prone to try things out. Like I noticed in lists we can delete things. Let's see if we can delete something from a dictionary. So del and delete the element, right? The pairing, the relationship with 2 and whatever, and I can in fact remove those definitions. So it's like you went in a library, you went, I don't like this page of Q's, I'm just going to rip that out. I don't recommend doing that, but it's very much like that. So I can delete these associations, but it's just as easy to create new associations. I'm like, you know what, I actually don't want to get rid of 2. I want to keep that association in there. My fault. I can actually say first dictionary, and you can see the only thing I have here is 1 is related to carrot. I want to say, well, 2, I want to put that back in and make it equal to 2. And it's back already. So I can add and remove very easily, very intuitively, without knowing a lot of things.
Now, Justin, are you when you do the either delete or you're doing the re-addition or the addendum to the dictionary, notice you only used the number 2. You didn't do 2:2 or the other way around, any of that. You just said this is the entry that I want to delete, and it deleted the entirety. This is the portion that I want to add, and it added the entirety of it. Is that because of the association?
Exactly. So these come in what are called key value pairs. So in this case, in this dictionary, I have 2 keys, the words 2 and the word 1, and then I have 2 values, the number 2 and the word carrot. So these key value pairs come together. It's all or nothing, right? So I have a key that is associated with a value, and then I have another key associated with a value. So when I delete the key entry, the value has to disappear because that relationship is now broken. So it's a very good, well, okay, why would that work? But it becomes very powerful, right? Now, that doesn't mean that I can't do something like this. First, dict2 plus equals 3, or excuse me, 2. Let's just make it 3 so it's not weird, a bunch of 2's. So this is saying set this, grab this, and increase that by 3. We'll see if it works. And it does in fact work. So I can now use this kind of like as a counter, like a way to go, well, 2 is related to these 5 instances of 2, or 1 is related to caret. I can use these as a collection of where I can create associations. And this will come in handy, as we'll see in just a moment. So I think it's best to actually go look at a program about how this would work. And I defined a dictionary like this, and I want to talk about how to iterate through those first, just to see how those work. And then let's do something a little more interesting. So when I iterate through a dictionary, there's a few different ways. I have a key value pair, as I said. So if I say for, right, I'm going to use what I know about lists for element in my dictionary. I'm just going to print the element. And let's get out of the shell. And fave sport, fave food, fave day. If I go back and try to reason about this, if I use this like a standard for loop, what do I get? What am I getting, Daniel? What do you see that I'm getting?
It looks like you're getting just the almost the subject of it, right? You're getting favorite food, you're getting favorite sport, you're getting favorite day, but you're not getting what those values actually are.
Right, exactly. So you made a key point. I'm not getting the value, but instead I'm getting the key, the lookup value. So over here on the left are the keys, and their associated values are on the right. So that's that mapping that I'm talking about. This was what you would look up in a standard dictionary, like if I'm carrot. Oh, okay. It is a small tuberous ground vegetable that is high in beta carotene. But that's okay, because if I can grab all of those and iterate through those, then I can in fact iterate through the values also, because now I have a variable that allows me to access the corresponding values. And just to show you that I'm not being crazy, you can see it prints the element, then the associated value, the element, the associated value, the element, the associated value. So I can create these structures that create relationships that incredibly powerful. But are you ready to do something that maybe you can see if you squint your eyes a little bit, may be a little applicable?
Let's do it.
You ready? You ready? Okay. So here's what I'm going to do. I'm going to comment this out. We don't want all that printout. And I'm just going to create a variable called logs. And I'm just going to lean on the keyboard like so. It's a real scientific process, Daniel.
Yes, it is.
So here, right, I now want to count. I want to count how many times does a J appear or a K appear, which could be associated with an error or a log or a debug info. So I can say, okay, my logs count is equal to, and I'm going to create an empty dictionary. So I have a dictionary now. I can add and delete from it. There's nothing there, so I have nothing to delete. If I try to do that, well, I guess we could try that and see what happens. I think it's important to see the errors that we may come up. So I'm going to say del logs count, and let's just give it some key, 7. If I try to run that, it again gives me a key error. It says, hey, you can't delete something that's not there. So that's important to know. That key error has come up a couple of times. But what can we do here? I'm going to say for every char in logs, and I know I'm going by character, then I'm going to say if char equals to j, and here's where we start nesting these things. if char is in the logs count, and this in for dictionaries means, is there a key that corresponds to this? So is there a key J? Or better off, if I come out here and just say logs count of J, could I do that without getting a key error? So if that character is there, then I want to say logs count character plus equals 1. So I'm going to increase that by 1. So every time I come to a J, if J is already in the logs count, then I'm going to increase it by 1. Else, logs count. Got to be careful there, Daniel.
Get you every time.
Get you every time. I'm just going to say, otherwise, when you've come to it, if it's not already there, put it in there. So this, we've added, significant complexity. I've added a for, a condition, and notice I have a condition within a condition. And now I'm starting to see, okay, these can be a little tricky. Got to be careful with our indentation. Got to be careful with, our reasoning. But even then, it's still fairly readable. Would you agree, Daniel?
Yeah, it's definitely not too bad. We start seeing the conditional statements. Those are relatively simple. If this, then do this. If not, then do something else. And that's why we have the else there. So very cool. And then we have the for loop, which is iterating through a certain condition.
Exactly. So, and then at the end, let's just print logs count. And clear and up. And there are 33 J's in there. And if I imagine this to be, oh, okay, this is a variable, maybe it means error, maybe it means there's a log, or maybe these are the things I need to delete. How many things do I need to delete? And should we turn it up a little bit? Should we
put a little more fire on it?
Just put a little more fire on it. Are you ready?
Uh-huh.
Yeah, I'm ready. So let's just say I have the alphabet. And this could be representative of all the things that I want to do. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Did I get all of them?
I think you hit every 26 of them.
Oh, I got tired there for a second. So for every letter in the alphabet, let's just tab that over one. So for every letter in the alphabet, for every char in logs, if char is equal to, and instead of J, I want to say letter. Let's see how that changes our output.
This ought to be interesting.
Hey, it may break, but I'm not prone to errors, but I hear they exist.
Yeah.
And there we go. There are 7 A's, 14 C's, 11 B's. And now I have quickly counted through that giant string that was hard to figure out. I've teased that apart. And now, with a little more, I could just, boom, put this into a file, something of that nature.
Yeah, this is definitely really cool. That, as you can see, we start using the basics of what Justin is showing us to start fleshing out. And he's right. This is really interesting for things of like log nature, where I can say, if I know that every error is going to start with a star or a capital E is because it's going to say error, and that's a unique condition, I can just go through and look for that, count them up, or maybe even deliver those lines back, output that to a file, or just output it to the screen. A lot of ways in which we can use this to parse through. Log parsing is one of the most non-fun jobs that we have as system administrators, network administrators, any kind of administrator. You're going to be looking at logs, and going through them can be a pain. There are third-party tools out there, but you have to work within the confines of that third-party tool. If you get a little Python underneath your belt, you can make it customized to your experience, making it much more efficient, and that is why we're showing you this stuff. Very, very cool, Justin.
Yeah, and I look at this output, and you said parsing through log files, parsing through any files, and what I mean by parse, I'm not saying I have, but I have heard of people who have opened those up and went, oh, there's one, write that down, there's another one, write that down.
We call that the hard way?
Yeah, that is definitely the hard way. I don't recommend it. I weep a little bit when it happens. Not saying I've done it, but I hear that it happens. This is not a great, this is a better output than we had before. But what if we could make this a little better, right? So I wanted to print out these in comma separated value form, right?
So you got to put a little makeup on this.
Yeah, I'm just, okay. So
Pretty it up.
I know at the very end my logs count has all the information that it contains, but I want to make this to where it prints out in it. Okay, this is delimited. Cool. We saw that we can use a for loop to print through the keys and then access the values. But there's sometimes we want to be able to access those easier and see how those relationships without using this syntax right here, my dictionary element or bracket element, or how the lookup would work. So there's actually a method on dictionaries called items. So if I say for key value in items, right? So I add that little bit of extra stuff there. That one method call in the dictionary, and then I add this value. Let's just see what this prints out. So I'm going to print the key, I'm going to print the value, and boom. Okay, that's a little better. A is corresponding to 7, but that's still not great. It would almost be better if I had these in comma separated form. And I have to bend down here because my highlighting's a little weird. So what if I say the output string for each iteration is going to look some key, comma, some value, and then I'm going to add this /n format and key, comma, value. So do you have a guess of what that /n is, Dane?
Yeah, because I have a little bit of programming experience. I'm guessing that stands for the new line character, which is going to basically give you a return. It's going to, it comes to the end of something and then drops it down to the next line.
Exactly. Now, since we're using print statements in an iterative structure, we don't actually have to put this here. But this is in preparation of what if I wanted to output this to an actual file that then I could open in like Excel or LibreOffice Calc or something of that nature. Then this is necessary because otherwise they'll just run together along in the same line. So I'm going to print the output, and let's see how that works. Ooh, so now I get A, 7, C, 14, B, 11. And if I pull this into a spreadsheet utility, I could sort those, I could create histograms, and this is kind of a hokey example, but you can see I could count the errors, count how many infos, give me some basic statistics about these large gigabyte log files or term papers that I'm searching through.
Yeah, you basically in about 3 lines of code created a comma separated value file.
Yeah, yeah. The first time I did this, it made me incredibly happy. I was like, yes, yes. So, we've learned a great deal about dictionaries, but I wonder where else these could be used, right? So I've done this count in the logs, done this incredibly complex, for within a for, if within an if, else if, counting through this just mishmash of strings, right? And notice I didn't actually count the semicolons because I'm like, I'm just doing a lookup here and seeing if these are equal. These are the things I care about. This allows me to skip over the things I don't care about. So these relationships are powerful. But dictionaries and lists and other things, strings provide us other ways to spit back information from functions. So I think it's good to see this last little, I can pop these apart and just spit back and return the elements that I need. So let's just create a function. We haven't created a function in a while. So split comma, right? And let's just say it takes a string. And then what I want to do is split, I'm going to make an assumption. I'm going to assume that this string has a single comma in it, and I'm going to split on that comma and return the first half and the second half. I'm going to return it in a dictionary with those keys as the relationship, first and second. So I can say my split list is equal to string dot split comma, and then I can return a dictionary, and I can define it in place. And you know, you saw that I had this already made. How would I make this dictionary without saying create an empty one, add a new key, create an empty one? I can actually say curly brace in curly brace and say, okay, the first half is going to be split list, and since I know there's going to be one comma, I have a 0 element and a first element. So I can say 0. And then I can say second half is split list 1. So now when I use this, if I pass it a string that has one comma in it, that's my assumption, then I will get them back as 2 halves in a dictionary that I can then use. So I now have a function that returns a dictionary. Let's go use that function. I'm going to comment this out just so we don't have this output. So this is my halves. How do you spell? Yeah, there we go. So split comma and tomato carrot. So I have the string that's all run together, and I want the first half and the second half. This could be a line split, where a lot of times you'll have something colon something else, like in various text files. You'll see that separation. This would be a way to go, okay, on every line I want to split this right there and get the first half and the second half. And they're not exactly halves. But now I can print halves, and if I clear and run, then I can see that returns to me as a dictionary that I can then use and reference. I can iterate through this like any other dictionary, but I've extracted that split value into a function that's descriptive and gives me data types that I can now work with.
Wow, that is extremely cool to be able to just create that function and then say, now when I need to add to my dictionary, I just throw it in here down in my code, a couple of lines. Here's the associations I want to create, and throw that in there for me. Would you create that dictionary? It was super simple. It was nothing to it. That's what I'm liking about Python so far.
That's what most people like about Python. That's what draws me to it, because as I've always said, I can have an idea and have it down 5 lines of code in a couple 10 minutes.
Awesome stuff. So Justin, is there anything else about dictionaries that we want to go over before we wrap up the show?
No, we've actually covered a great deal. We've utilized a lot of the things that we've already learned: iteration, decision making, the use of dictionaries and functions all together to do a couple of examples that we're starting to see the full power of Python. So I think we're good.
Awesome stuff. Well, Justin, thanks again for just stopping by and giving us your wealth of knowledge and experience with Python to help us become young Python masters one day ourselves. That being said, we've got nothing else to go for on dictionaries. We thank you guys for watching. I hope you enjoyed this episode, got a lot out of it. We appreciate everyone that watches and views. So we thank you for that. Hopefully we'll see you in the next episode. As for this one, signing off for IT Pro TV, I've been your host, Daniel Lowry.
And I'm Justin Dennison.
We'll see you next time.